Hello, everybody. Welcome to Power Break. I am Bethany Rue, Director of Programming and Communications at Gridmates. I'm very excited to welcome as our guest today, Lincoln Bleveans, the Executive Director of Sustainability and Energy Management at Stanford, a small university out west. Maybe you've heard of it.
You may have heard of it. Yep.
You may have heard of it. Lincoln, welcome. Thank you so much for joining me this morning.
Oh, it's great to be here. Great to be here. Thank you.
Yes, well, so you are our inaugural guest. This is our inaugural episode, and I couldn't be more excited to have you be a part of it. I'm really looking forward to a great conversation, so let's just dive in.
Sure.
What is the number one item you want to implement at Stanford that will make the biggest difference in the energy consumption at Stanford?
Well, we are in a really interesting situation at Stanford. We have had a very, very aggressive push towards energy efficiency over the last 10 plus years. So a lot of the low-hanging fruit is gone, but at the same time, we've also built a now $600 million thermal plant that supplies electricity, we've built a $600 million thermal plant that supplies hot water and chilled water to the campus and does heating and cooling for the campus. And what we're working on now is our ways to find efficiency and optimization in the way we use the thermal energy in the same way that the electricity industry has gotten really good at finding efficiencies in the way we use electric energy. And of course, thermal energy is very different. It moves a lot more slowly. It's a lot more subjective in the way that people in buildings perceive it. But we see a lot of potential there to find opportunities to really optimize around that and in a way that is absolutely transparent to the scientists and students and teachers who are in our buildings.
And I have a little side question to that. How involved are some of your university staff, some of your university professors in this process? Or, I mean, you've got a lot of brilliant minds there. Do you ever tap into them to help come up with some of these campus-wide solutions?
Absolutely. I like to joke that, if you throw a rock at Stanford, you probably hit a Nobel Prize winner. It's literally that kind of intellectual horsepower and academic horsepower. And we have done a lot of collaboration with the academic side. But frankly, I think only scratched the surface. We are working with professors and grad students and undergrads from energy to water to waste, sustainability, little larger issues around climate like resilience. We do a lot of it. We can do a lot more. And, ultimately we see Stanford as a living lab for a lot of these things. We really want to be and are on the cutting edge of making climate change, sustainability and climate change resilience, taking it, out of the theoretical and making it real.
Well, so obviously then you are already converting some of your staff and professors there into energy heroes and helping you kind of work towards achieving Stanford's overall goals. When you come across somebody that might not be of that same mindset, like, they should be working towards a cleaner energy future, what are some things that you do or say to them to help convert them into energy heroes?
Well, I think you have to meet people where they are. I think there's a segment of the population, at least in the US, that is never, ever going to make the jump to seeing climate change and recognizing climate change. So I think you have to meet people where they are. Former California Governor Arnold Schwarzenegger had a great formula for this, which I'm going to steal here, which is, if people aren't willing to talk about climate change, talk about things that are related to it that they do see, like pollution. So let's put aside the change in climate if that's something that isn't going to move the needle for someone. But let's talk about pollution. And as it turns out, talking about climate change and talking about pollution, you often end up at the same solutions, maybe with a different sense of urgency, but some progress is better than no progress. And I see that as a very effective way to go, especially when it comes to things like air pollution. People are very, very aware of that, whether it's from automobiles or power plants or wildfires out in California. So you have to meet people where they are.
It sounds like what my mother used to do, sneaking the peas into my mashed potatoes. Very similar tactic.
Very similar, yes. If my mother is watching, I know that the parsley in the meatloaf was actually spinach.
Yes.
Yeah.
See, and so there, your mom taught you your approach to energy heroes. I
Yep.
love it. So what new, obviously you were so familiar with many, many different clean technologies and clean energy technologies, just based on where you are and what you're doing. So what are what is the one that you are most excited about? Clean energy technology. Just gets you jazzed in the morning.
For me, it's all about storage now. And when most people think about storage, we think about batteries and conventional batteries, whether it is, the battery in your mouse, or it's the battery, utility scale battery at a substation or what have you, or at a solar project. That to me, I really see that as the personal computer circa 1985. I think we are going to see not just tremendous advances in things that we already have, like lithium ion, but I would love to see tremendous advances across different use cases, chemistries, and form factors that have different applications. For example, something with much longer duration than, say, a typical lithium ion. But I think that there's a larger issue here too, and that is that when we look at something like lithium ion or solar PV, for example, looking at technologies that are incredibly clean in operation and have very low societal and environmental impacts in operation. But when you look at the life cycle, you're actually looking at a big negative impact on the front end in terms of rare earth metal extraction, processing, and then recycling or disposal on the other end. And so to me, the most exciting part of innovation going forward is not just the capability of the machine, but finding ways to make the machine truly low impact across its life cycle. Let's get the cobalt out of the equation. Let's get the other rare earth metals out of the equation. Let's figure out a way to dispose of things, or better yet, recycle things, so we're not creating what I think of as a repeat of the nuclear era, where we have this wonderful, clean, carbon-free energy and this very big long-term environmental problem. Let's not create another nuclear situation for ourselves. Let's address those externalities now, as opposed to kicking them down the road.
So clean up, clean energy, right?
Clean up, clean energy. Very good. Yes.
Wonderful. Well, on that note, Lincoln, I'm going to wrap this up. The whole point of Power Break is we want to keep it short and sweet, but super informative, which is not remotely a problem talking to somebody like you, Lincoln. You are somebody I could definitely go at least 2 or 3 hours with on this. But for the sake of the show, we're going to wrap it here. Thank you so much for joining us. And if people want to find out more about what Stanford's doing, where can they find more information on that?
If you Google Stanford Sustainability or Stanford Energy, you can see what we're doing in my group in terms of energy and sustainability and water and waste and everything else. But there's also a lot going on the academic side too. There are institutes. We're actually putting together the first new school at Stanford in over 70 years focused on climate and sustainability. So
wow, that's no small feat, putting together a whole new school from scratch. So this must be something you guys are relatively serious about.
We're pretty serious about it. Yes. Thank you.
All right, awesome. Thank you, Lincoln. Take care.
You too.